Hey everybody, Bill Sky, the COBOL guy, and another video. This time we're going to talk about, this is our first video where we actually talk about the procedure division and how to actually do logic. Now we have to do this a little bit at a time, so what we're going to do is we're going to talk about just moving data around. And I think you're going to be really surprised at how flexible and useful moving data around is in a COBOL program. So a little bit verbose, you got a lot, instead of just the equal sign for assignment statement, you've got to use the move verb. But you're going to see some real big benefits of COBOL moving data around, so let's get going. All right, I've got a project all set up here, and I just called this project moving data. You can see it up here in my editor. And I've got some variables in there, and we're going to be using variables and literals and stuff. So as I've said in other parts of this course, is that the procedure division is where you actually do your coding. Now you might think that this is so archaic that you've got different divisions, but I don't know if you know it. C and C++ also have these divisions. They have a data section. They have a stack section, which is kind of like a dynamic memory section. They also have a text section, which is the actual procedure division, the code section. So these things are really separated in assembler language at the CPU level. And it just so happens that because COBOL was one of the first high-level languages out there, it kind of mimicked that a little bit. So whether you know it or not, or whether you like it or not, programs are divided into divisions, and the procedure division is basically the text section of any assembler language program. And C++ and C, they move to assembler or they move to machine code, but they're still organized in that fashion. So you've probably seen this a million times if you've been watching any of my videos. What I'm going to do is I'm going to go in here and I'm just going to move some data into a variable. Now we've got a WS counter, that stands for working storage counter. We have another one here, local storage. I'm actually going to delete this LS counter, the local storage section. And I'm going to make this, I'm going to create a variable here. I don't know. I'm just going to call this some integer. And I'm just going to say a usage is comp1 and value is 0. And then put a period. Now I always like to, whenever I do stuff a little bit at a time, I always like to build it. Looks good. We're using the GZC COBOL compiler here, not the IBM COBOL compiler. However, the syntax is pretty much the same. So if I want to move data into a variable that I've defined, I simply use the verb move. So I'm going to say move 10 into some int. And actually, it's really not an int. I should say this correctly, into some float, because a comp1 is a floating point. Okay, I'm going to go ahead and build it. And it's not into, I believe, move 10 in, or no, it's 2. Oh my goodness, move 10 to. There we go. Now let's display some float before we move data in it. So I'm going to say display some float. And then I'm going to copy and paste that after we move 10 in it. So we should see 0 and then we should see a 10. Okay, so let's go to the terminal. And there we go. Hello world and 0 and 10. So that's how you move a literal in. Now what if we have a string? Let's go ahead and create a string. So I'm going to say some string. And strings are display. So I'm going to say pick x32. Value is spaces. And now let's move some data in there. So before I do that, I'm going to say display some string is. Then I'm going to move some data in there. So I'm going to say move silly Billy to some string. Oh, I think I'm in C here. And then let's go ahead and display some string. And let's run it, and there we go. So some string is spaces. Now if you notice, after the 10, I can't really select characters in the output. However, after the is, I can select 32 characters because I moved spaces into that area. So they're ASCII, I believe it's hexadecimal 20. And then you can see Silly Billy here, and there's some spaces after it. And that's because it's pick x32. So really, a string, as I mentioned in my videos on creating data, a string, a display string, is kind of like a C string where it has in C, or C++ for that matter, which has a specific length. It's not a variable length type of data item. So that's moving literals. You can, instead of moving a 10 into some float, I can move 10.99. That's an actual float. So we can see our 1099. So you can move integers. Now this is a comp1 is a float, but then we've also got other usages for like just an integer and things like that. But we're just doing some simple things of moving literals into variables. Now what else can I do? I can also move variables into variables. So what I'm going to do is I'm going to copy some string, and I'm going to call this some string 2. And then I'm going to move some string to some string 2. And then I'm going to display some string 2 is some string 2. Let's save and build that. And run it, and you can see some string 2 now has Silly Billy in it. Okay, so that's pretty simple. We're moving data into different data types. What if I move an integer, or let's say if I move a float into a string? Let's see what happens when we do that. I don't even think compiler will let me do that. So I'm going to say move some float to some string 2. Let's see if the compiler will even let me do that. And it doesn't. It gives me an invalid. It just tells me invalid move statement. It doesn't really tell me what the problem is. But it's not allowed. Now I can move a comp1, which is basically a floating point. I can move that into a display float. So I'm going to say some dfloat pick 999.999999 value is 0.00. Now why would you want to move it into a different type of a float? Let's get rid of this bad boy right here, or bad girl, whatever gender you wish it to be. So why would I want to move a comp1? Why would I want to move a floating point into what I call a display floating point? It's because you want to format the number correctly. You want to format specifically as 3 integer portions, a period, decimal point, and then in this case I think we've got 5 or 6 decimal digits, fractional digits. You want to display it that way. If you see right here, 10.99 is 10.99, right? But what if I wanted to display it as 010.990000? What if I wanted to display it that way? So let's actually do that. So let's say move some float to some dfloat, and then we're going to say display some dfloat is with a period. And you can see that it has been formatted in such a way where it gives me more accuracy. And if you notice, you might say, well, wait a minute, that's not accurate. .989999 is not .99. Well, for your information, .99 as stored in the floating point unit of a computer is not .99. It is .9899999999 because of the way floating point numbers are actually stored in memory. So again, if you're interested in why that happens, take a look at Bill Sky, the assembly guy, take a look at my floating point videos and I'll show you why that happens. But a little bit past the level of this particular video. Okay, let's talk about moving structures around in a COBOL program. What I'm going to do is in my working storage section, I'm going to create a structure called employee data 1, and then I'm going to create some data within there. So I'm going to say, I don't know, let's say employee ID pick 94. Oh, let's make it 96. 05 employee F name, first name. We're going to make this one pick X32. 05 employee last name pick X32. And I don't know, let's do one more. Employee zip pick 96.95, because you can have a zip code that has that. Okay, so let's go ahead and save and build that. So there's our structure. Now let's create a second structure, and I'll tell you why we might want to do this. Let's create a second structure. I'll call this employee data 2. And let's say we've decided to add a phone number. Employee phone, exchange, pick 93. Actually, it should be area code first, right? Yep. You could even add country code. Let's stay in the United States for now. And then 10 number. Okay. Now, let me explain why you might have a program. Oh, we can't use the word number. It's a reserved word. So I want to call this P number for phone number. And that's better. So why would we have such a thing? Why would we have two structures that are so close to each other in a COBOL program, or for any program for that matter? Well, let me give you this scenario. You've got an application that was written, I don't know, 10 months ago, and your application is supposed to be keeping track of your employees. And for some reason, the design was not done very well. So what they forgot to do in the employee database, in the employee file, is they forgot to load the employee phone number. So what we're going to do in this program, not literally, but what we're thinking about doing in this program is read the old data from the file, put that old data into the new data structure, and then add a phone number. Add zeros or whatever, or maybe even manually do it. I don't know. But some way that you're going to actually fix the problem of the original design. You're going to be converting the data file from only having 4 fields, which is employee ID, name, first name, last name, and zip, to have, what is that, 7 fields, employee ID, first name, last name, zip, phone number, area code, phone number exchange, and phone number. So you want to do that, and you're going to write a program to do that conversion, and then you're going to go in and add the phone numbers once you get that file all set up. So that's a great way, or a great reason why you might do something like this. Now, you might look at this and say, oh, this code is going to be horrible. Let me go in here and delete this code that we've got here that we were playing around with. So let's say you're going to do something like, I don't know, you're going to, let's put a comment here, read a record from the file into employee data 1. So I haven't done a video yet on reading data from a file, but let's just pretend we have. Let's say we have read a record from the file into employee data 1. Now, how am I going to move the data from employee data 1 into employee data 2? Well, I could do something like this. I could say move employee ID from employee data 1 to employee ID of employee data 2. And let's save and build that. I might have the syntax wrong. I don't think I do. And I believe it's in, employee ID in, not from, it's in, which makes more sense. Okay, let's save and build that. Okay, so we do that for the employee ID. Then we have to say move, oh, I'm thinking assembler there, move employee fname in employee data 1 to employee fname in employee data 2, and so forth and so on. So you have to do that for every field within the structure. Now that's what you would have to do in a C program to be absolutely sure you can't just move the data or copy the data from two different structures. You have to move it. You have to move them one field in the structure at a time. However, COBOL has a really neat feature. I'm going to say move corresponding employee data 1 to employee data 2. And I think I've got that right. Let's go ahead and build it and make sure. Yep. So what this one statement is going to do, it's going to move every piece of data that has the same name in employee data 1 to the same name in employee data 2. Employee first name is going to go to employee first name of employee data 2, and so forth. Now you're not going to have anything moved into here, into employee phone number. Well, you wouldn't have it moved into there either if you did it this way. You'd have to move some values in there. So what you could do is, you could do something like this. You could say move zeros to area code in employee data 2. Let's save and build that, make sure I've got my syntax right. And you could do the same thing for exchange or P number. Or you could do something like this, value is 0. So let's just copy that. And then you don't have to worry about moving zeros into it. As long as you don't put any other kind of data in there, then you don't have to worry about it. Wow, talk about it, convenient. So one line of code will move everything inside of employee data 1 into employee data 2 with the same name. Now that's a very important thing that I just said. These 05 level structure variables must be the same name for this to work. Otherwise it won't move anything in there. It'll just move the ones that are duplicated. So that's actually pretty neat. Now if we had a debugger, I could show you actually how to do this, or we could just display it. I could prove to you, and let's do that. So I'm going to say display employee ID in employee data 1. Oops. Display employee fname in employee data 1. So I'm going to move those above the move corresponding. And then I'm just going to print employee data 2 variables. So let's make that. Let's run it. Well, it's all zeros because we didn't move any data in there. So let's do this. Let's say move. Actually, let's not do that. Let's put some values in here. So employee ID of employee data 1, value is, let's make it all 9s. Employee name, value is Bill. And we're not going to put any values in the ID or the first name for employee data 2. And you can see it moved it in there. So here is employee data 1, that was the ID and the first name, and this single line move corresponding, employee data 1 to employee data 2, put Bill and the ID, the first name and the ID, into that employee data 2. So pretty cool. Now you can also move constants into variables. We talked about moving literals. You could also move constants. So let's say if I have a constant here, interest rate, value 6.5. I could also move that into a variable. So I could say move interest rate 2. And I think we have a comp 1 here. Yep, some float. Display some float. Let's go ahead and save and build that. So pretty nice. So you can also move constants. Now what else can you do? Well, we talked about if you've got duplicate names within a structure like employee data 1 and employee data 2, how do you differentiate those duplicate names? And we did that down here in the move corresponding, where we said display the employee ID, which is an 05 level variable, within the 01 level variable. So I think that's the reason why they allowed that, to have 05 level variables have the same name as the other 05 level variables, because the 01 level variables must be unique, and then you can do things like move corresponding. So very, very useful. Okay, there's something else that you can do to move data into and out of variables, but this is mainly just mathematical variables. I could say, or not mathematical, numerical variables. I could say compute some float equals 100. Let's say if the compiler will let us do that. Yep. So if you just want to, if you refuse to use the move and then the to keyword, you can use compute, and that basically says do a Fortran or a C or a C++ like calculation. In this case, we're just moving a value. I could say, I'll say compute some float equals some, let's see what else we got. Some, let's see what we had here. We had, oh, we can use the constant. So we can say some float equals interest rate. So that's another way to do it. I don't think it's used that way. Compute is, I've never seen this in an actual production COBOL program. Some of you may have if you've been a COBOL programmer in your past, but I've just never seen it done that way. The move is really the way to do it. All right, so that's our first procedure division video on just moving data around. We moved literals, we moved strings, we moved numbers, we moved display numbers, we moved floating point, we moved constants, we moved structures, entire structures, something you really couldn't do in C or C++ without a function or something like that, or unless they were identical, right? If they were identical, then you could do that. But if they're not identical, not easy to do. So, hope to see you in our next video.